This video will describe the 6 types of reactions that we'll be having to understand and identify in class. The first type of reaction that we're going to talk about is a synthesis reaction. A synthesis reaction is where you have 2 separate either elements or compounds, and they come together to just make one compound. An example of a synthesis reaction would be hydrogen gas and oxygen gas coming together to make water. Now, these large numbers in the front will be in another lesson. It is used to balance that equation, but 2 separate things making one is identified as a synthesis reaction. The next kind of reaction that we have is a decomposition reaction. And just like what the word sounds like, decomposition means to break apart. That would mean that I have one compound to begin with, and it breaks apart into its constituent elements. If I had several things, this is only showing 2 elements, so it would break down into individual elements. But if I had multiple things over here, I could break down into a compound and an element, or I could break down into 2 compounds if I had far more things here. An example of that would be the compound water breaking down into hydrogen and oxygen. The next kind of reaction that you'll have to identify is a single replacement reaction. A single replacement reaction template could be either one of these 2. And that would depend on whether or not the first thing that you had, whether it was a positive or a negative ion. This one is showing a positive ion first and a negative ion first in this next one. So let's look at the positive ion one first. That is showing you have one single element and it is positive, plus a compound that, this is an ionic compound, so it's made up of a positive and a negative ion. When you have a single replacement reaction, you still end up with a single and a compound. However, this positive ion replaced this positive ion, so A is going to then be bonded with C, and B, which was the same kind of ion as this one, ends up going home alone. The other kind that could happen is the exact same looking thing. I still look like I have one and a compound breaking down and recreating into another compound and a single element. However, this is involving the single being a negative ion. That would mean that it's going to replace F when it recombines on this side. And E will go home with D, and we always write the cation first. That's why we wrote E and D. And then F went home by itself. An example of that, using a ion that is a positive ion, is Fe, iron here, is going to replace the positive ion, which is H2 in this compound of H2O. And Fe goes home with the O. See, Fe is going home with the O. And the H, which was a positive ion, is going home by itself. The next kind of reaction is a double replacement reaction. In a double replacement reaction, I have 2 compounds. Double replacement reactions are ionic. I have 2 ionic compounds, and they reconfigure to be 2 ionic compounds. The positive of the first one goes with the negative of the second one, and the positive of the second one goes home with the negative of the first one. An example of that would look like this, where I had lead was my positive ion. It replaced the K, so then the K went home with the nitrate, and the lead went home with the sulfur. So that is a double replacement. In a double replacement, you have 2 compounds as your reactants and 2 compounds as your products. You have a combustion reaction. Combustion reaction is when you have oxygen reacting as a reactant by itself, and you have a variety of different ways. You can be a compound reacting with oxygen, and everyone will get oxygen in their product. You can have an element reacting with oxygen, and still everybody's getting oxygen with their product. Or you can have a specialized one with a hydrocarbon. A hydrocarbon is a carbon-hydrogen compound. If you have a hydrocarbon, you will always get carbon dioxide and water as your results. So here are some examples of those types occurring. Here's a compound first with oxygen, and everybody gets oxygen. There's oxygen in that compound and that one. This is an element combining with oxygen, and everybody has oxygen in their compound. And this is that special case of a hydrocarbon where I have carbon and hydrogen bonding with oxygen, and CO2 and water will always be your results. There is one other type of reaction that I failed to mention here, and that is an acid-base reaction. And in an acid-base reaction, it is a special kind of double displacement. However, in the first spot, it's hydrogen, because everything that starts with the element hydrogen is an acid. And in the second spot would be hydroxide. And what I would get on the other side would be a salt and water. And that is an acid-base reaction, which is a special kind of double replacement reaction.